Welcome to Formal Charts. This is our fourth video of our 8th unit of AP Chemistry. Lewis structures are useful, but they're only representations of actual molecules. They're not always authentic. They're really just our best idea of it, which means sometimes they can be wrong, but more often we can have multiple that are correct. A way to determine which Lewis structures is, or sometimes there's multiple that tie, are the most correct is by the use of formal charge. The formal charge of any atom in a molecule is the charge that the atom would have if each bonding electron pair in the molecule were actually shared equally between its two atoms, which does sometimes occur if they're like the same element bonding to each other. But oftentimes you've got polar bonds going on, you've got partial negative charges. This just kind of helps us keep a closer track of what's happening with the electrons. So to calculate the formal charge on any atom in a Lewis structure, we assign electrons to the atom according to the following rules. Number 1, all non-bonding electrons are assigned to the atom on which they are found, which means that your first step is to make your Lewis structure. Hopefully you gather that by now, but if not, that's okay. And you then assign electrons to the atom, meaning every non-bonding atom, so it's not, we typically call them lone pairs, are actually given to whatever atom they're currently bonded to. Alright? Step 2. For any bond, half of the bonding electrons are assigned to each atom in the bond. We're basically keeping track of how many electrons each atom really can say is theirs, if you will. And in a bond, if they're equal, well, they're not really either one of them, so they just both get half. Once electrons are assigned according to the above steps, our formal charge can be found by the following equation, if you will. Now, my equation is going to be vertical, if you will, because I couldn't quite fit it horizontally. You may put it horizontally, it does not matter. But a formal charge is defined as our valence electrons, so we're counting those actually from the periodic table. From that, we're going to subtract half of our bonding electrons, so any electron actually associated with bonding, we're basically subtracting half of those. And from those, we're subtracting all of our non-bonding electrons. So, our formal charge is our valence electrons minus half of the electrons that are actually bonding in it, minus any of its non-bonding electrons. Alright, now let me give you an example real quick. Our formal charge for oxygen in this case would be its valence electrons, which is 6, minus our half of our bonding electrons, which would be 1, minus the non-bonding pairs, which are 6. That gives it a formal charge of -1. And actually this one over here would also have a formal charge of -1. The bottom oxygen would be 6 minus 2 for the bonding electrons, and minus the non-bonding electrons, which are 4, which gets you 0. Nitrogen, lastly, is 5 minus 4, and then minus, well, 0. Because there's actually no non-bonding pairs on nitrogen. That gives it a +1. Now, this goes along, this gives us kind of an idea of basically that these two oxygens are basically taking a little bit more electrons, so this one's kind of not really kind of sharing a bit. Nitrogen, if anything, is losing. That's similar to what we call oxidation states, which is where we actually deal with the electronegativity. But the benefit of this is that overall, this is nitrate. And nitrate has a 1- charge. If you add up all the formal charges, they should always equal your actual overall charge. -1 plus 1 is 0, minus 1 is -1, plus 0 is a -1. That's formal charge. So, to determine the best Lewis structure, often we call that the most dominant structure. We consult the following guidelines. The dominant structure is the one in which, number one, the formal charges are closest to 0. Now, this won't always happen that they're all 0, but ultimately, that's kind of what we call our most dominant Lewis structure. Number 2, however, the negative charges reside on the most electronegative atoms. So the ones that really should be taking the electrons are the ones that get the negative charge. So, keep those in mind. Lastly, please note that these charges do not represent the actual charges on atoms, because we're assuming that everything's shared equally. It gives us a better distribution of just your normal Lewis structure, and gives us an overall better idea of really what's actually happening with the electrons. Alright, so for the 3 resonance structures of NCO-, A, draw the structures and assign formal charge to each atom, and then B, figure out which structure is dominant. So, try it by yourself, draw the structures, assign the charges, come back in a bit and I'll have them up here. Okay, 3 resonance structures, their formal charges. Ultimately, we need our actual formal charges as close to 0 as possible, but we also want to make sure that if that isn't enough, that the negative charge is on the most electronegative atom. Well, this one has all zeros, but here's the issue. These don't add up to our overall charge. 0 plus 0 plus 0 is not -1, which means this is not our most dominant. This, we have a -1 on oxygen and a 0 on everything else, adds up to the formal charge. That sounds like that's probably going to be our most dominant, because oxygen is our most electronegative. Looking at this one, we see that actually it puts the negative charge on nitrogen, which means that will be wrong. This is our most dominant. That's formal charge. Thanks for watching.